Hi, in this lecture we will decide that what are the different types of languages available and what are the respective grammars and the respective automata. So that means this lecture will give you the complete bird's eye view of the formal language and automata theory. Till date, whatever languages we have seen that the left hand side must consist of a variable and right hand side it's a combination of variable and terminal symbol. It may be a to a or it may be a to aa or it may be a to asb or these are the languages that we have seen, right? So all these languages where the left hand side is the variable and right hand side is the combination of variable and terminal symbol, or in a general manner we write the language as a to x, where a belongs to variable and x belongs to variable union terminal symbol star. So all those languages are called context free language. Now out of this context free language, if we can construct a regular expression from this language, then that language is called context free as well as regular. Suppose if I consider this example a to a, from this I can easily construct the regular expression. Regular expression is only a, and for this one a to a is an incomplete expression. I have to stop this a. So if I give lambda or a to a, then a to a and then capital A is lambda. If I consider this one, then what will happen? What should be the complete language? Let us derive this expression. So if I derive this expression, I will get that a to a is there. Again this a will be replaced by a, then I will get a. Then again if I replace this one, then I will get this one. So if I stop this a with lambda, then I am getting a. So in the first replacement I am getting a single a, second replacement I am getting 2a, third replacement I am getting 3a. In this way it is being increasing, right? So the entire regular expression I can represent it as a star only. So as we can represent this expression also with a star, so I can say that this language is also a regular expression. But in this case, instead of s, let us consider this one as s to asb and s to lambda. So for this expression, the language is lg equal to anbn, as we have already seen. But we cannot construct a regular expression for this language. A star b star cannot be a regular expression, that I have already discussed in my last lecture. So this language is not regular, this one is not regular. So what is the in brief, if I want to say that out of these three production rules, first two is regular as well as context free, but the third one, that is context free but not regular. So we can say that all languages that are context free are all languages that are regular are context free also, but all context free languages are not regular. Similarly, apart from regular and context free languages, there are some more languages are there. Suppose if I can represent a production rule like this also, AAB to small p capital S small q. So this types of production rule is also possible. Apart from the production rule A to AA or A to A or S to ASB slash b or slash lambda. Now if these types of production rules are there, where the left hand side consists of the sentential form, that is the combination of variable and terminal symbol, as well as the right hand side also consists of the sentential form, then these types of languages are called context sensitive language. These types of languages are called context sensitive language. Means that in case of context sensitive language, the left hand side may consist of variable as well as combination of variable and terminal symbols. So if I write in a gist that all are context sensitive language, because the left hand side consists of variable as well as terminal symbols also context sensitive. Now out of this, these three are context free. This one is not context free because the left hand side is not variable only, it consists of terminal symbol only. So out of this one is only regular. Now can I say that a regular language is a context free language as well as a context sensitive language, but a context sensitive language may not be a regular one. Similarly, context free language is also a context sensitive language, but the opposite is not true. Means a regular language is a subset of context free language is a subset of regular language. Now another kind of language may be possible where the left hand side may consist of only lambda, right hand side may be any string. So if the left hand side consists of variable terminal symbol as well as lambda itself also, that the whatever be the production rules that are available in the universe of this course, so all will be a part of unrestricted language. So this one is called unrestricted language or recursively enumerable language. Not only this one, all languages will be unrestricted and recursively enumerable language. So if I broadly write it down, then I can write it that this one entire thing is also is called recursively enumerable language or unrestricted language. Unrestricted language. Now unrestricted language is sometimes called type 0 language. This one is type 0. Context sensitive is called type 1. Context free is called type 2, and regular is called type 3. So in the examination you may be asked, a production rules will be given to you. Now you have to find out whether the language is type 0, type 1, type 2 or type 3. Now we can say that type 3 is a subset of type 3 language is a subset of type 2, type 2 is a subset of type 1, and type 1 is a subset of type 0. Or on the other hand, we can write it as unrestricted language or recursively enumerable language is a superset of context sensitive language, which is a superset of context free language, which one is also a superset of regular language. Now this is the language and its hierarchy is there. Now let us see what should be the hierarchy for the for its corresponding grammar as well as automata. So if I write it down separately here, all the language. So all the available languages is a part of unrestricted language that we have seen already. Out of this unrestricted language, few of the languages are context sensitive. Out of this context sensitive, few of them are context free and few of them are regular language. Now for the grammar itself, the grammar corresponding to unrestricted language is called unrestricted grammar. The grammar corresponding to context sensitive language is called context sensitive grammar. And then context free grammar, then regular grammar. Similarly, for the automata, the regular grammar and its corresponding automata is called finite state machine or FSM. The context free language and its corresponding grammar automata is called push down automata. Context sensitive language and its automata is called linear bounded automata. Unrestricted language and its automata is called Turing machine. So what does it mean? That the regular language, the set of rules that requires to construct the regular language is called regular grammar, and the respective machines is called finite state machine. Now similarly, the context free language, if we want to automate it, then it is called push down automata. Context sensitive language, if I want to automate it, then it is called linear bounded automata. Unrestricted grammar, that means any types of grammar or any types of language, and if I want to convert it to respective machines, that is called Turing machine. That is why Turing machine is called the universal machine, which can automate any kind of machine, and it is named after the famous scientist Alan Turing, who is called the father of computer science. Now the entire picture is developed by one great person, that is called Noam Chomsky, and this entire hierarchy is called Chomsky hierarchy. So this shows you what are the different types of languages that are available, and what are the different types of respective grammars, and what is its respective automata. So this gives you the bird's eye view of the entire subjects, formal language and automata theory.